Hello, everyone. Christopher is on his way.
I'm
Welcome.
waddling from behind this here setup. Hi, guys. Oh, my goodness gracious.
We are the Dinosaur Omelette.
Hi, friends. How are you? Yes, hi. Welcome back. Sorry about last week. We're redoing a video we did last week, The Science of Chicken Poop. It's actually very intriguing. It's cool stuff. We're going to go through some light chemistry, not high school level stuff, because I don't like people get very intimidated by it, so I'm not going to go deep into that. Yeah, but we're going to go through what's actually happening. It's really fascinating, and your chicken manure is quite useful. In fact, if you have a group of chickens, 10 chickens, you're producing more fertilizer every month than you would get in a 10-pound bag of, what is it, NPK fertilizer, the 10-10-10 fertilizer, nitrogen, phosphorus, potassium fertilizer, right?
I guess so.
So cool, we're going to talk about that. Welcome in if you're new here. Give me a, what do you call it? Hit the thumbs up, do something nice. It helps us out a bit. And I do put quite a bit of effort into these educational videos. Homestead people are self-sufficient types. They're self-teaching. They're self-reliant. They're not time wasters. So this is valuable information for that group of people. It's a niche segment of the population. So we like you guys. Let me make sure my voice is working here. Okay, good.
Oh, maybe we should introduce ourselves, our names.
Yeah, we do have names.
Yes, I'm Angela.
Hi, I'm Chris. Christopher, welcome, Dinosaur Omelette. I've been doing these videos for, I guess, 3 or 4 years, well, 4 or 5 years. Been a long time. Started out on the Facebook, we're now here. Check down in the description of these videos. I always leave links to educational material, which I write for family. It's family-oriented material. It's easy to read, but it contains sufficient information that you're going to have a proficient knowledge or working knowledge of the stuff being presented. Would you agree with that?
Yeah.
And I always like showing this because we specialize in jumbo paternic quail. We raise those for food and aid programs. And Angela has a delightful silky chicken program with Dino Puffs. Here's your little sign. Here's a little sign. I do all the art. I like drawing. It's not AI. The sign's starting to fade. Anyway, we do that. But down in the description is this PDF. It's really useful for learning how to raise quail from beginning to end. And it gives you all that information. And that's that. What is a quail, by the way? They're little birds about this size. They also produce manure. And we'll talk about that in just a moment. Anything you'd like to add, dear wife?
No, I mean, we encourage people to learn new skills and become, as much as they can, self-sufficient and learn about homesteading and producing foods and however you're able to in your situation, your circumstances. But yeah, and improving the quality of your life and your family, doing family stuff and being outside. So yeah, a lot of the animals and the things that we talk about here has to do with those topics.
Precisely. Hi, Katie. How are you? Katie, I think you're going to like this. This is actually a good piece of information. So I'm going to start in like 2 minutes. But the reason I'm doing this is because I'd often hear people talking about chicken manure. And they're like, oh, you can't use it, it's hot. I'm like, huh, what does that mean? I don't know. But they would say it's hot. So I'm going to teach you why it's called hot, how it's formed, what's going on chemically. We're not going to do difficult chemistry stuff. Like I always like to do stuff that's presented for like a kid level to adult level. Like I always like Einstein's quote. You know, he said, if you know material, no matter how complicated it is, you should be able to teach it to a child or teach it to somebody young. So you can, and I like doing that because we're going to talk about fundamentals and not really the specific stuff. I love all your chats. Always great info. Hey, thanks.
Oh, thank you.
So we're going to talk about the cycle that nitrogen, I'm beginning now. Welcome in. Today we're going to be talking about the cycle of what's going on with nitrogen in the chicken's diet from feed down to expelling it as waste and the decomposition of its waste back into the natural cycle. So a lot of effort on the homestead, whether people are aware of it or not, is they're trying to reincorporate everything into a system, permaculture kind of, like a permaculture system. There's not going to be waste, the ecosystem is being utilized. And this waste product, or what you think is a waste product, can definitely be used. And we want to talk about what is actually happening, what is this compound? Because people are not really familiar with it, particularly new to chicken people. This is like, I guess, mid-level kind of information.
Mm-hmm.
And what's actually happening with all this chicken crap? Is it just a smelly waste? No, it's not. It's actually quite useful and very, very beneficial for gardening, soil, reinvigorating, bringing soil back to life. And we'll talk about why. Okay, anything you'd like to say or ask? I have a big chart. I'm going to go over my chart. Don't get scared with my chart when I bring it out.
Yeah, I don't think so. Not at the moment, because I think you're going to cover, different things. Like there are differences in manure types, like animal types, like the birds versus.
We're just talking about the birds.
Well, right. We're not getting into in depth with the other ones, but the the hot value is
we'll talk
different.
about that.
But, yeah.
Yes. Okay, so I'm going to bring out this flow chart, and I'm going to walk you through what's going on so you can understand what's happening. But before I do, let me just give you a very brief synopsis or breakdown. So the chicken, well, actually, let me bring that out here. It'll be a lot easier because I'm a visual dude. Okay, can we see that?
Yeah.
Can I have my pointer stick? It's not really a pointer stick. It's a yellow stick. Okay, I'm going to walk through and give you guys a brief background again about chicken anatomy, or basically its digestive system, basic introduction to digestive system. I hope you can see this teeny tiny chicken chart. Okay, and by the way, guys, if you go into my previous live stuff, I go over their vision, digestive system, their
closer.
How they breathe. Yeah, you may not be able to see this, but I'll be blabbing loud enough. Hopefully,
yeah, you'll go over it.
This is the stuff I don't want you guys being scared about. Like, these big scary words. Nitrogen, ammonia, ammonium, nitrate, nitrate. And here in green, uric acid and urea. Now, I'll explain what this is. You don't have to memorize any of these numbers. But they're all the same thing in a way. Okay, all of this stuff goes back to mother nitrogen, okay, from the protein they're eating. So who's eating protein? Mr. Chicken's eating protein. How is a chicken's digestive tract built? Well, it's very different than ours, boys and girls. We swallow stuff down, and the esophagus goes down to the tub, or the stomach. Chicken's a little different. So we've also, if you guys are wondering, especially you younger people, chickens do not have teeth. They can't chew up their food. So
in their mouth area, anyway.
They don't have teeth in their mouth, so they peck, and they can swallow solid food, and it goes down to this cool little storage area called the crop. That's where the food is kind of stored, kind of like a lunch bag. Some water goes in there, it moistens up a bit, and it prepares to go down into what's called the proventriculus. That's a big word, proventriculus. That's kind of what's referred to as their chemical stomach, like kind of a human stomach is a chemical stomach where acid is breaking foods down. It goes into the proventriculus to do some pre-digestion, and then it goes to this very unique specialized organ called the gizzard. It goes into the gizzard. The gizzard is where the chicken is doing its chewing. It's breaking the food down. And when we chew anything, remember the old story, chew your food 24 times? So
something like that, yeah.
We humans should chew our food because we're not just grinding it down and producing surface area, but we have digestive enzymes in our mouth. So it actually begins digestion here in the mouth. But chickens don't have that. So they swallow everything and it gets down to the gizzard, and that's where the grinding occurs. That's why we offer small, hard pebbles to the chickens. They know how many to eat. They're not going to overeat their stones. They know how many to eat to facilitate that grinding, right? Mm-hmm. After gizzard, it's going into where the majority of absorption is taking place, just like us, in the small intestine. And off to the side of the small intestine, their food is going to go into these pouches called the ceca, or cecum, plural. Those are fermentation pouches, kind of like our large intestine. The food is fermenting partially, or undigested fibers are starting to be broken down a little more. Finally, the stuff that we all are talking about today goes into the cloaca. That's a receiving area for eggs and their chicken poop and their waste, and it comes out of the vent. I like how they call that vent.
Mm-hmm.
What was that?
The sewage, something like that.
Yeah, it was something from Latin. The Latin word
Latin
meant
or Greek?
sewer. Anywho, so that's their digestive system. It's not too hard to understand that, but cool stuff you guys should know about, of course, is the gizzard and I think the cecum, or these fermentation pouches. So why am I telling you this? Well, this is where all the magic happens. This is where their poop is coming from, and this is where all this really cool chemical process is taking place, particularly over here in the liver. The liver is going to be pretty integral to what we're talking about tonight. All right, so what is the chicken eating? What's the chicken eat?
They eat all kinds of things.
What
If they're
kind of stuff?
scavenging, they're going to be eating bugs and grubs and grasses,
Yeah.
and they'll eat, like meat, snakes and frogs, like whatever
Snakes
they
and
can get
frogs?
to.
Yeah, they eat
They're
snakes
gonna
and frogs.
eat,
They'll eat dead mice.
grains. If they're being fed, by humans, then they'll have whatever they need
Okay.
put in their bowl.
So what is the macronutrient that gets the chickens huge and jacked up and ready to go fight?
Protein.
Protein. That's right, proteins. So we're going to be talking about protein breakdown. What are the proteins? Proteins are made of what? What are those building blocks called?
The amino acids.
Amino acids, right. And in the proteins we have nitrogen, and the amino groups have a nitrogen backbone. This is important. So when the chicken is breaking down these proteins into their amino acid groups, we're going to have waste. There's always waste. But that's what biology is all about. Efficiency in the system to keep the thing functioning in homeostasis and staying alive and acting well. Oh, by the way, if you guys have questions, pop them down in the bottom. So they're going to have waste. So the chicken's eating and it's digesting and it's breaking apart the proteins to use the building blocks to build its own cells, to build different, all kinds of fun structures, enzymes and etc. inside of the chicken. But even so, there's going to be waste. So what happens is you're having what's called an amine group, A-M-I-N-E. These are amino acid groups that have a nitrogen backbone or nitrogen component to it. And the chicken, it processes in the liver. It gets converted. These waste products, these waste amine groups, these nitrogen groups that are waste, this is where we're talking about this stuff here. It gets converted into the liver into ammonia. Everybody heard about ammonia? What is ammonia? Let me talk about that real quick. Ammonia is nitrogen. What? Yes, it's true. Ammonia is a chemical form of nitrogen. NH3. Nitrogen, 3 hydrogen. You don't have to know that. It's a chemical form of nitrogen. Ammonium, another compound that's being created in the chicken. That's another form of nitrogen. So why, and then we talk about nitrate and nitrite later on. But why is ammonia ammonium? I know you guys know what ammonia is. You smelled it before. Everybody, you smell like urine. It's got that smell. That's ammonia. Mm-hmm. Why is it called ammonia? So this is a good one for the brain. Back in the olden days of chemistry, before modern days of chemistry, a couple of fellows were digging around and they found I think it was a type of salt in a town or an area in Egypt called Ammon. Guess what they named this salt after? They burned it and they sniffed it and they're like, oh, God, this stuff we got from Ammon smells pretty bad. Let's give it a name. We'll call it ammonia. So that's right. And it was a nitrogen compound. It was NH3 that they discovered and they wound up sniffing. Interesting, huh? Yeah, that's how that got its name. So ammonia is a type of nitrogen. That's why it's in blue. Everything in blue is an inorganic compound called from nitrogen. All right, are you with me, people? Are you with me?
Mm-hmm.
Okay. So I'll go back so we can get this through. Chicken is digesting protein, has leftover nitrogen or waste material, and converts it. That is a fun fact. Pretty cool, bro. Oh, thanks. Yeah, I thought it was pretty cool. And I thought it would be something we could remember, because now when you're at the party, did you know about ammonia? Do you know why it's called ammonia? Comes from Ammon. Anyway, so I'm going to go back and forth so we remember. So the protein, after it's being digested, broken down, we have waste product nitrogen. The liver converts it into ammonia, which we discussed, named after Ammon. But here's the problem. Ammonia is extremely toxic, okay? It will make the bird no longer be an alive bird. Well, what's going on? If it's producing this toxin, what's happening in this bird? It immediately converts the ammonia into a stabilized waste product called uric acid, an organic compound. Kids at home, if you don't know what an organic or inorganic compound is, the difference is organic compounds have a carbon component to it, a carbon backbone or a carbon component bound to carbon. So uric acid is an organic compound that the chicken takes. The ammonia will immediately be converted so it doesn't kill the chicken. It's turned into the waste. And actually, here's one you guys will recognize. You ever see piles? Well, I'm sure you've seen piles of chicken poop, and you see that white stuff on top? That's uric acid. That's uric acid. That's what that is, that little bit of stuff. It's about 2 to 4% the total volume of what they're excreting. Why do they do this? This is a good science piece of information for you guys about your chickens that you probably didn't realize. So chickens, pretty related to lizards like snakes and whatnot, and
like
other reptiles, dinosaurs, if you will.
Mm-hmm.
They conservation. They're going to conserve their water. They don't want to waste water. So urinating is not good for them. These are designed for flight, etc. They have a bunch of physiological needs that mammals do not. So they do not want to waste water by flushing out toxins with water. So what they do is they create a solid waste. Chickens don't pee. And I don't think dinosaurs ever did too. I really get upset when I see these dinosaur documentaries and they show a dinosaur urinating. That never happened. The dinosaurs likely also produced uric acid. So that's what the chickens do. To conserve water, they take the wasted ammonia or the wasted nitrogen and convert it into a solid crystalline form called uric acid. Or if you want to say it fun, carbon 5, hydrogen 4, nitrogen 4, oxygen 3. That's the chemical ingredients if you want to go make it at home yourself. Mm-hmm. But you have to be a chicken.
So that's the white stuff in the manure.
Yeah, uric acid. And in fact, that's what's dangerous to plants when we talk about hot. Like, oh gosh, that's a hot manure. No, not exactly. Kind of, sort of. That's the hot component, or leads to it, because there's other players in the game of manure breakdown. Who are the other players? The soil bacteria. You know, I haven't even looked at my notes, so maybe I should look at my notes. I always feel like I gotta look at my notes. Do professors look at their notes? Not that I'm a professor. So.
And then you have this whole.
Yeah, I think I'm going pretty good with this. Yeah. I mean, I know all this stuff. I'm just seeing if I'm missing anything. Yeah. No, I think we're doing good. Okay, cool.
It seems. I mean, it's making sense. It's flowing.
Yeah. So, like, what is the manure actually comprised of? You have the uric acid. What else is in there? I forget, but I don't really want to get too much in that because we're just talking about uric acid. The bulk of it, the stool, the brown, the blah, that's undigested. That's non-digestible or undigestible plant matter. There's organisms in there, bacteria, okay, pathogens, things that can be dangerous. So if you dump the manure without the uric acid straight onto the garden, chemically, it's sound. It's not going to damage the plants like the uric acid would. However, biologically, it's a dangerous thing because there's pathogens in there that can propagate. We want to kill the pathogens. We want to kill anything that might be dangerous or unsafe. right?
So what makes it dangerous?
Well, you could have salmonella or other infectious agents. Yeah, infectious agents. So we want to kill the infectious agents, and we do that through the composting process. In fact, I'm going to get down here in a second. We talked about deep litter systems. That's a type of composting. What's happening in the composting and why it's a safe alternative to constantly cleaning out a coop, if it's done properly, is because during the breakdown of these organic compounds, bacteria get involved. Not pathogenic bacteria, but bacteria that are specifically used to break down plant fibers and the stuff that's coming out of the chicken. They heat it up. It gets hot enough where two things are happening. The heat is ending the life of the bad guy bacteria. They can't survive in the heat. And the good bacteria begin to thrive. And when the good bacteria begin to thrive, it's like they're a really obnoxious bunch of people that just moved to the neighborhood. They take up all the resources. So they're eating all the good stuff, and then the bad guys, they're out-competed. This is very common in pathology with disease. It out-competes the bad guy organisms, where they're eating everything and taking up all the resources. So the bad guys can't prosper in that compost. It's too hot. They're eating everything. I'm getting out of here. I'm not going to be salmonella anymore.
They just broke.
And they go. So that's what's happening in the compost. So down to this fascinating story of chicken poop. I know she's not talking much. I'm just blabbing. So
That's fine.
we talked about protein metabolism, the amino acids breaking down. The liver removes excess nitrogen, turns it into ammonia. The uric acid is formed, the crystalline substance, that white cap, that's uric acid. The liver converts it, conserving water, because birds are flight-designed animals. They have high metabolism. They have a high body temperature. They want to stay light. They have those light bones, so they don't want to have a lot of weight, and they don't want to waste water because they really respirate a lot, so they're losing water. So they want to conserve water, so they don't waste water. So they want to get rid of the ammonia as a solid, and they turn it into a crystal substance to be expelled as a solid. How about when using a tractor-type cage? Hi, John. Thanks for the question. In what way are you talking about using a tractor-type cage? Are you talking about composting? That's probably what he's talking about, I'm assuming.
Well, tractor-type cages tend to be moved periodically to prevent buildup of waste and manure.
Yeah.
So I'm not too sure. Just let us know a little bit more what you're thinking there, as far as manure waste products go.
Yeah, just be a little. I wish I could answer that. Like, you can be thorough. I like questions, and if you have to take a couple of lines, that's fine too. Okay, uric acid we talked about forms of crystals. They get rid of solid waste. They excrete it. Feces contains uric acid. It's expelled via the cloaca, or the vent, and that's their manure. Now this is when it begins its external breakdown. So whether it's composted or not, obviously it's going to start breaking down in the environment. In the compost, so we're tossing this stuff into the compost. It's going through what's called an ammonification. Ammonification. What is ammonification? You're going to find this very interesting. The nitrogen is kind of like doing a bounce. Boing, boing, goes from nitrogen to ammonia, to nitrogen to ammonia. It's doing this bounce a couple times in this cycle from feed to earth, back into the plants. So it's being converted several times by bacteria and by the animal itself. So ammonification. So the uric acid, the crystal substance in the compost, is going to be turned back into ammonia compounds. Bacteria in the soil, Bacillus and Pseudomonas. Don't ask me too much about them. I really don't know very much about Bacillus and Pseudomonas other than they do the ammonification. So they're taking the uric acid and they're breaking it apart again. They're breaking it apart and it's being converted back to ammonia and ammonium. Two different things. Ammonia and ammonium. If I'm getting ahead from everybody, or if I'm going with too much info, let me know. Okay, random thoughts. Combining, say, rabbit poop and chicken quail poop with the cold of rabbit help offset the hot of chicken quail poop. No, don't do that. I'll explain why, not to yell at you. Because it's still going to break down. It's still going to get hot. And I'll tell you why it's called hot in just a second. Where was I? Ammonification. So it's turning back into ammonia and ammonium. What is the difference? Ammonia is, so when moisture gets into this uric acid, it starts to break it apart and we get ammonia. That's when you smell that. It's the water soluble form. It's just that smelly gas, the ammonia gas. Mm-hmm. Ammonium is the stable form which will stay in the soil. You're not going to smell it. So if there's too much moisture in your compost, you may begin to smell ammonia. So add some more, what do you call it, leaves? Green,
brown materials like shavings, straw, leaves, even cardboard, but like the brown materials.
Yeah, and I'll talk about the timing of this because you still want to turn the compost because the bacteria, they suffocate, they need air. So we want to turn the compost. So yes, so we're turning the uric acid, that solid crystal, back into ammonia in the compost pile. That's the hot process. That's where the heat's coming from. When those bacteria are tearing that thing apart and they're producing a lot of heat. So when we say the manure is hot, it's not chemical. It's it's thermogenic. It means it's go ahead.
It's getting up there. It's like 120 to 150 degrees. Is that correct? It's quite hot. So it's quite literally hot in temperature.
Yeah, and so down in the soil and the little roots, if you look under a microscope, there's these microscopic little fibers that are like trying to, and then you burn them up.
What they need from the soil.
So you can burn the roots.
So the temperature of that manure is burning the roots.
Well, the breakdown of the manure, the bacterial metabolism.
The whole process.
So John said, with the pathogens and being hot compost, is it a bad idea? Any options or thought on it? I'm not going to give veterinary or any other kind of advice on this, but logically, I'm going to make the assumption that it's going to be the case of, I always like to talk about this, dose determines the poison. A couple pieces of chicken manure are going to be exposed to a broad a broad environment, and thusly it'll allow oxygenation, breakdown, water, etc. And when it begins, just like in a chicken house, if it piles up, it becomes overwhelming, and the bacteria outcompete everything, and then you have a disease situation on your hand. So people commonly tractor, and that's why they tractor them, because they let them soil the area a little bit and then move them out of there. They're
soiling, and they're eating the grasses. But moving them out of the soiled area is definitely important to do. If you are moving them at all, if you're not moving them, if they're in a tractor type cage system, but they're stationary, then you're going to want to have a deep litter system.
Yeah, so if you're talking about, is it going to kill the grass in the immediate area? Yeah, if it's a lot, but everything will bounce back 10,000 times stronger because you're going to have a huge nitrogen, stable form of nitrogen in the soil for the next generation of plants. And I've seen that happen a ton. But
it can be, based on whatever your space that you're working with. But before the grass gets to the point of death or just too much attention,
it'll make sense.
Then you can move them.
It'll make sense. If you don't know about this, once I explain this, it'll make sense how to manage that a little more. Kelly's here. Hi, Kelly. We're talking about chicken poop today.
Hi,
it was actually really interesting.
And this is quail, too.
Yeah, quail's a little different, but yes. Actually, quail's only a little different in the amount of compost to dry material. So, because they have a higher uric acid content. All right, so we're talking about ammonification. And I keep going over this whole process so you guys don't get lost. Chicken eats, creates leftover nitrogen. Body converts it into ammonia compounds. Liver converts that immediately into uric acid. Uric acid is that white cap on top of chicken poop that everybody knows about. That's a stable form of ammonia or nitrogen. Ammonia is a different type of nitrogen, different chemical form of nitrogen. So we have that stable form being excreted by the chicken, going into the compost pile, and then it's breaking down in this first stage of ammonification, turning it back into the ammonia forms of nitrogen. This is done by bacteria in the soil. And again, as a systems guy, it's really, really amazing how we have all these organisms present naturally in the soil that do this process and help everything work quite well. Oh, Kelly said something. Last week there was a weird glitch, and I think I missed it. Yeah, it's this YouTube, man.
Yeah.
It kicked me out because I was going to do this last week. All right, so we have ammonia, which is the gas. We don't like that. That's smelly. They first produce ammonia, and they convert it into ammonium, a stable form. That's not going to be a gas, so you're not going to smell it unless there's too much water. If there's too much water present, the bacteria are not getting enough oxygen, and thus the gas can be produced. Otherwise, they're going to capture it and turn it into a stable form of nitrogen, a chemical form of nitrogen called ammonium. You're not going to smell that. Okay, so what's happening now is it's going to go through another process. That's what I said. It's like a bouncing ball. It's turning into ammonia back and forth. Is there much difference between quail and chicken poop? It's going to be in the percentage of uric acid produced in the quail is a little higher. I have the numbers. I'll
Does
look
it
it up.
have to do with like the protein, the diet that they eat?
Yeah,
being
because
slightly different.
they have a higher protein. If you saw this from the beginning, what's happening is the uric acid being produced, the thing that's burning the ground, is leftover nitrogen from proteins that are being broken down in the bird. So with quail, they have a little higher protein diet and they have a higher metabolism. So they're processing everything a lot faster. So they're producing a little bit more ammonia per volume, per weight, if you will. Okay, so we went down here, blah, blah, blah. Ammonification, we're taking this poop, taking the uric acid, turning it back into ammonia. And now there's another class of bacteria in the soil, these aerobic soil bacteria, meaning they need oxygen. Nitrosomonas oxidized, that's their name, nitrosomonas, nitrogen. These are nitrobacteria. They convert that ammonium into what's called nitrite, with an I, nitrite, NO2. What does that mean? A nitrogen with two oxygens. Do you guys remember that from chemistry at all? If not, I'm not going to explain it because it's a lot of stuff. But they convert it into nitrite. It's not quite stable enough for plants. So you have another bacteria, Nitrobacter. Nitrobacter is the name of the last bacteria in this process to convert nitrite into nitrite. Nitrate. That's the important one. Nitrate. Nitrate. Nitrates are the stable form of nitrogen that are then going to be available for the plants to absorb. Down here, can you see that? Yeah. Plants uptake the new nitrates in their roots, the NO3, and they put it back into the amino acids and the new proteins that the chickens are going to eat. And then we feed production. We pick the plants that are growing from here, pick those plants, that becomes a new feed, and the chicken starts the process over again. So it is a bouncy ball. Protein to ammonia to uric acid to ammonia to nitrates, back to amino acids and proteins.
So it's nourishing the plants that are growing, and then the plants are harvested for the
Yeah, and all those proteins have nitrogen in it. Yeah.
Yeah.
Cool. I hope that wasn't too wordy or complex. And there's a lot of jibber jabber here. But I think this is a very interesting thing. Now we're going to talk about time frames because John was asking about quail and chicken and all these fun stuff. Where's my fun notes? Set my stick right here. I feel like I ate a sock. My mouth is very dry.
Usually you drink water.
Okay. Time frames. So the hot portion. Hot. Uric acid breakdowns. Proteins, carbon material are being introduced. So anyway, okay, the uric acid breakdown and the carbon material being mixed and introduced. This is week 1 through 4. Where are we at here? Okay. About 1 to 4 weeks. So this whole process for, what do you call it? Composting.
So that it's no longer hot and it's
not just no longer hot.
But it's ready for plants to be nourished by.
Yay! Yeah. So not just hot, but to where it's broken down, stabilized into nitrate, and available for plants. It takes some time. So it takes about 4 to 6 months. It's going to take a little longer in the winter. You're still working. So if you go out in the winter time and you dig up a compost pile, what do you see? Do you know what you see?
No.
Steam. Because those little dudes
yeah.
are still eating. They're comfy down there. It's nice and warm down there. Because
And if you're doing like a deep litter system in your coop or wherever, you'll notice that it's warm. And you'll notice that even more in the wintertime.
Yeah, so yeah, that's
because
for sure.
That whole process is happening. Yeah. It's not dangerous. It's actually quite healthy if you're maintaining it properly.
Yeah, the breakdown, the bacteria act like an organic miniature heater in a compost system or in a deep litter system in that closed coop. You're thinking, if you're not familiar with that, you're like, ew, so you keep chicken crap in a coop? Yes. However, it's not really chicken crap because we talked about this. It's a new product. It's a new compound that's being eaten by bacteria that are breaking it down. And when they do that, they do produce enough heat to where it's going to increase the ambient temperature in the chicken coop. So people are like, do I need a heater in my coop in the winter? Don't do that. Like, people do that, but don't do that because it causes several problems I don't want to get into besides stress and thermal.
But it's not just manure. It's obviously bedding, appropriate amount of bedding mixed in and maintained.
I think we did a deep litter video.
I think we did.
I think we did a deep litter video. So where was it? Okay, so week 1 to 4, this hot period, this ammonification, it's breaking down. It's smelly if it's wet. So none of this stuff should be smelly. In fact, once we get down here, once we get down here, there's that real earthy, brown, spongy stuff called humus. Humus. You may want to pronounce it like hummus, like that delicious chickpea, but that's that organic, spongy, water retention, aerated compound. And Mother Nature makes it. It's really amazing. So it takes all this foul rot and turns it into this delicious, brown, disease-free
nice
soil. Yeah, it's exceptional. And if you do it properly, you got this healthy super garden additive that will outperform any of those store things you're doing. Organic farming. So week 1 to 4, this is the hot period. It's going to get about 130 to 150 degrees. So it's killing off the bad bacteria, like we were talking about, that will be present in the bulk of stool. You got nasty pathogens that might live in there. But in that high heat environment during that hot period, it will get rid of them. And Katie, that's what the hot was referring to. We talked about earlier, and I mentioned earlier.
So you're saying that mixing chicken manure or quail manure with rabbit, something that's not hot, wouldn't really work because the chicken and bird manure is still going to get 120, 150 degrees, even though it's with that other type of manure. Is that what you're saying?
Yeah, so I know exactly what you're thinking, Katie, because it makes sense. Intuitively, I'm going to dilute it. So if I dilute it with this, it shouldn't be a problem. You're still going to have, I would always compost stuff, like just because of the potential pathogen, particularly with avian critters, the birds. Rabbit, maybe not so much. But definitely with the birds, you probably want to compost everything, not just because of the nitrogen issue, but because of potential pathogens. Right? Because so the birds, they carry organisms in them, and they develop a resistance to a particular pathogenic load. So like they're carrying, what do you call them? Parasites and other bacteria. That's not infecting them. It's just in their local environment. They just develop a symbiotic kind of almost relationship with the critters. Not really symbiotic, but they develop a resistance.
They're hardy.
They're hardy.
And like you said earlier, the amount the load determines how well they're going to handle.
Yeah. Katie said, "I love the explanation. Thank you." Oh, you're welcome. I hope this is useful. Like, and especially if you have kids, if you want to talk about this with kids, I hope this stuff I am saying here is easy enough to incorporate, to reiterate to somebody, especially young people. Because it seems like when you see this stuff, it's like, oh my God, not that again. I did that in high school. But you can ignore all that. Like, the basics are pretty easy to understand.
And again, for the process to work the best, and according to the right amount of time it should take, and for everything to be working healthily. You wouldn't want to just dump pure manure into your spot and that's all you're putting, because then that's, what is it? Is it nitrate or nitrite that's seeping into the soil? That can go into the water systems and stuff. You wanna put,
It's probably the
what's like cow farms and stuff.
uric acid and ammonia.
Yeah, it's one of the, anyway. You want to make sure you're mixing like brown materials, like we mentioned earlier, the straw, the shavings, the leaves. Just brown materials definitely help. Mixing in with the manure helps the whole process go proper. And then of course the tending to the compost.
Yes.
Yeah.
Yes, indeed.
That's just a basic info.
All right. So, yeah, week 1 to 4. It's about 1 to 4 weeks for this hot period. I guess 1 week if it's summertime and you're doing a lot of whatever. Mm-hmm. Let's just say 4 weeks. This is where you're going to be turning it more frequently because, again, these are aerobic little critters. They like air, so they need oxygen. So you don't want to have it saturated, wet, and matted down, which can happen. Even in the rain, like what's happening is it creates its own kind of, what do you call it? Like, roof. Yeah. And you do get runoff, and if it's composting properly and if it's aerated properly, it'll drain properly, so it's not going to saturate it and it'll dry out pretty quickly. But yeah, during this first 1 to 4 weeks, it's going to be running hot, 130 to 150 degrees, really warm, and the bacteria need air. That's how they eat and do their chemical stuff. So you want to turn it every 5 days to 7 days, every week or so. You want to get in there and turn it. So people who actually maintain those compost pile, you'll see them out there turning it. Or they have those commercial little mini tubs where people,
yeah,
you're not producing too much, but it's still cool.
There's a couple comments there.
This should be pushed to all kinds of homeschool curriculum. Y'all have such an awesome way to explain complex ideas in simple terms, definitely adding to homeschool kids' syllabi. Oh, awesome.
Thank you.
What up, tapping in to show support. Oh, hey, it's Chef Barbecue. What up, man? Hey, good to see you again. Thanks for the support. We're talking about chicken poop. Fun stuff. All right, so 1 to 4 weeks, returning every 5 to 7 days. This is, ladies and gentlemen, this is the how to take care of our compost pile section after we learn what's happening with our chicken poop. Week 4 to 8. Okay. So this is only a 2-month area. It's a very short period of time for the initial breakdown of these compounds. Week 1 to 4, we're turning every 5 to 7 days. This is where the immediate uric acid breakdown is happening, turning it into the ammonia and ammonium. Week 4 to 8, it gets cooler because they have less material to eat. They're kind of like, ugh, we got filled. That was a party, man. And just the stragglers are hanging on. Still eating, but not as much. So it cools down to about 120 degrees or so. And they're like, so they're not going, so they don't need as much air, so you can dial back the aeration. You don't have to turn it as much. So we're doing it every 2 weeks as opposed to every week. And this is where the bacteria kind of chill, and this is cool. This is where the fungus and actinoma, never mind.
Big word.
No. I was writing something else.
Oh.
So the funguses start taking over and they start to break down the compost, and the compost gets dark. Fungus. Forgot to mention those guys. Very important. I don't know what type of fungus. I'm not going that deep, and usually fungus have big names.
Yeah, they do.
I'm not a mycologist. I'm not really anything. But the fungus are taking over around week 4 to 8, and they're producing that humus. There's now the curing process. That's the long period. It's a cool period. And that's where the majority of time is spent during curing, 2 to 6 months. It's breakdown with fungal breakdown, etc. is going on. And the bulk of that humus is being produced in that longer period. But thankfully, by that time, those waste nitrogen compounds, uric acid, have been neutralized and turned into a usable form of nitrate. So in that, after curing, springtime comes up, right? You've been turning this pile for the last well, you haven't been turning it lately, but you've been taking care of this compost pile for 6 months or so. It's time to get the spring beds ready. It should be cool and ready to go with an abundance of healthy nitrate, which those plants absolutely need because that's the backbone to a lot of their compounds. And plus, contains phosphorus. There's phosphorus present in there, which is important for energy. Anybody remember ATP, adenosine triphosphate? It's that energy for the cell. Glucose gets converted into it. I know I don't want to get into that stuff, but yeah, it has many important compounds in there. Perfect topic. Let's go. Message retracted. You can say foul stuff here. I don't mind. So, cool. Is that all I want to talk about on that? There's something else I wanted to mention. What else are we talking about?
I have two things I want to mention, but it's
one
just a
last
side note.
thing. I forgot to mention this at the beginning. So I was talking about how birds, okay, and the reptiles, they do not urinate and produce liquid waste. They conserve liquid. They conserve water. They want to waste it, so they produce solids. But mammals do. Mammals produce urine, and instead of uric acid crystals, they produce urea. Okay, that's what's coming out. And again, it's another. If you see NH2, nitrogen, another nitrogen compound, and of course it'll break down and smell ammonia-like. Because where does ammonia get its name, everybody? Do you remember from the beginning? Katie, I bet you remember. Katie, I'm putting you on here. Do you know, where did ammonia, why do we call ammonia ammonia? Where did it come from?
There's that delay for them to answer.
I know. Do you remember?
Something about the Egyptians.
Good. Good. Close enough.
They're digging and they found something.
Oh, she says something about the, yeah.
They came across some sort of.
Hey, she got it right. Yay! Yay!
What did she say?
Ammon.
Yeah.
Yeah, it's an interesting story. You can look that up on the old interwebs. I'm sure they have a good story about it, but that was cool. So that's the story of chicken poop. Isn't that amazing? I don't know. Here's the thing, ladies and gentlemen at home, especially if you're going to be homeschooling and teaching kids. What I taught my kids wasn't just information. It was to have a desire to acquire information. Why is this? Because as we get older, we perceive time just speeds up. Of course, it doesn't. This is a perception. And I really think the reason we perceive that is because we lost the spark of curiosity. And we no longer continually learn. Like as little kids into teenage years and even early adulthood, we're continually learning and experiencing new things. But then we hit this kind of a culturally imposed plateau and we stagnate and it feels like time's flying because we're not doing anything. So continual learning, it's not about being some, intellectual goofball. It's just about the enjoyment of the wonderful creation that surrounds us.
And I think it takes more intention as an adult to pursue learning because as a child, everything is brand new. So that curiosity is just so easy to be fed because you're learning with everything, just being alive. So then once we grow older, it takes more intention, but there's so much. I mean, for goodness sakes, there's so much to learn. And I think inside of each one of us, we are still, that young child at heart.
I am.
Yeah, and that curiosity is still there and wants to be fed.
Yes, indeed. I agree.
Sir.
She said, I love Egyptian culture. Reading, I'm really curious. Did they really find 1/4 mile long pillars under that giant pyramid? Remember that? Mm-hmm. I don't know. Like I used to be a staunch Egyptian slaves built those things, but like the more you look about the size of those stones, the actual logistics of it and the mathematics, they'd have to be moving a stone every 20 minutes for 20 straight years.
To accomplish what they did.
It's amazing. Anyway. Perhaps
so I did want to mention two things. Just
do you need my chart?
Thoughts. I can say concerning compost piles and maintenance and just like extra stuff. One, I'm a big fan of black soldier flies because they're larvae, technically maggots, but larva sounds nicer, and they don't look so disturbing. They look like something you would find under a rock.
You'd want them as pets.
They look like something you'd find under a rock, the babies do.
Yeah.
But anyway, they eat this composting material. They'll eat, the manure. They'll eat, just whatever, things that are breaking down. They eat that. And so they'll start as, once they hatch, the larva will start small and then they'll get bigger. Once they get to about an inch long, which takes several weeks to happen, then they will come up to the top of the compost pile and then they'll become the soldier fly, which really it kind of looks like a small black wasp, but they're harmless. I don't even think they have a mouth.
If you like pie, you do not want to be a soldier fly because they would never be able to eat it.
No. Yeah, the soldier flies,
they don't have a mouth.
They're harmless. You can hold them. They don't live very long as that adult stage. But anyway, they're wonderful to have in your compost pile. If the temperatures get really cold, it's wintertime, and they're not, they hadn't gotten to that adult stage yet, then the larva will burrow down, however deep they have to go in the compost pile to stay safe from the frost. And then they'll kind of hibernate until the temperatures go back up. But they help break down the compost material and the manure much faster. They'll also, they secrete some sort of liquid fluid stuff that repels flies, because flies would be their natural rival. So they help to keep some flies away from the area. And they'll keep reproducing if you keep that source there available for them.
You will find that, like, what I like about all this stuff, like, we're not raising gigantic, huge industrial agricultural centers. This is like personal stuff. So you can use biology to do the work for you. Mm-hmm. And the biology does a really wonderful job. And that's why it's cool to learn about it. Like the black soldier flies. And those guys, they reproduce very rapidly. They reproduce abundantly because, animals that have short lifespans get eaten by predators. They got to produce a ton of them. So, and then it's in a controlled environment, so they're kind of safe. So you have a huge pile. You can pull them out and be like chicken treats. Chickens love them.
Chickens love eating them. And people actually can buy them dried for chickens.
They look like giant baby ladybugs.
Oh,
she said.
Okay.
Black soldier flies showed up here naturally, and they're so fast at breaking down. Totally agree. Highly recommend it.
Yeah, they're awesome. You can, if you don't have any, or you want to get going with your compost pile, you can always buy them online. Amazon has different types of retailers and such for the larva state. Another thing I've noticed just over time of using different types of bedding material in that end up in the composting pile. With the manure, so we work with straw, we work with shavings, which we have trays and an indoor setting, and I put shavings on there for the manure to go onto, which helps with smell, but also helps, of course, with the whole composting process. And then I started experimenting with the compressed pellets. They're pellets for like horse stalls.
Wood.
Yeah, it's essentially like sawdust, essentially compressed into a pellet. And I have
safe for animals.
Yes, it's safe for animals. I've come to really like it a lot. And the reason being, I use it in the outdoor setting. I use it like it's exposed to all like weather, to rain and everything. So it's in my runs, my chickens, and then I also put it in our chicken coops as a deep litter system. So what happens is if it stays dry, the birds will dig through it, and it doesn't take very long for it to break down out of that pellet shape and become, it's not like a dust, it's like a granular sawdust. So the birds...
Kind of like compost humus, that earthy stuff.
Yeah, and the birds love dust bathing in it, and they just naturally mix it. And when it's exposed to weather, to rain, it'll expand kind of like a sponge and then dry really fast and then be that granular dust. What I really like about it is it doesn't smell. The other bedding materials do smell, I've noticed, and when it's in the composting pile, eventually if I clean areas out and put it in the composting pile mixed in, I've noticed it breaks down pretty quickly the compost manure. And the result was just a beautiful soil, that humus stuff you're talking about, like very quickly. And the whole process seemed faster than using the straw. The bedding, I would say, the shavings would be better than the straw in my experience, and then the pellets just really nice.
The pellets. So surface area, like eating a piece of corn, swallowing it whole. There's no surface area. Chewing it up into a lot of surface area. So
with
the pellets,
being like a dust.
Yeah, so the pellets, unlike the straw,
Like
doesn't have a lot of,
tubes.
it's not a lot of surface area.
And then the shavings is literal, like,
Yeah, so air can
pieces.
get to it and bacteria can get to it. Bacteria are everywhere. I think, gosh, I forget how much, I'm not gonna quote it wrong. There's the amount of,
how much brown material versus manure?
biomass, living organisms on the land, on the earth, I think are like 10% of the weight is microorganisms. It far exceeds human. The majority of the weight is plants, which I think is like 70% of the biomass. So anyway, it's really interesting. So there's bacteria everywhere, and very beneficial. It's funny because you don't see them, but without them, nothing would be alive.
Right. Yeah.
I keep going on about this. Like when I was doing this promo for this video, I was talking about Dr. Mark Waltney. You know who he is?
Remind me.
He was Matt Damon from The Martian movie.
Oh.
So that movie, he's trying to grow potatoes in his own Mark Waltney leavings.
Species.
And the Martian soil. So the Martian soil isn't soil at all. Soil is a living thing. It's alive. So we don't think of dirt as living. We don't think of soil because we don't look at it under a microscope. But it is in a very, very living, thriving organism. And it's this cyclical living thing. It's really, really amazing. So on Mars, there's nothing alive in that soil. And the plants, the way the plants, you're not eating a plant, you're eating, well, you are eating a plant, but you're eating what it was able to do through the living soil. The soil and the bacteria in the soil are what make the plant grow. It's not the dirt. Okay, people think, oh, dirt. So if you want to do an experiment with the kids, you can take some soil from outside, boil it, kill everything in it, and keep it sterile, and see if something will grow in it. It won't grow. Even though you got all the nutrients in there, you don't have any of the chemical processes taking place with the plants. So like in a hydroponic system, right? What's going on? They're not just feeding them water. There's a solution added to that water so nutrients can get to the roots.
Right.
So the nutrients that the plants are getting aren't coming from dirt. They're coming from bacteria. And a lot of people don't know that. It's not something that we would think intuitively.
Well, with the water, it's like they have the fish and then the
aquaponics.
Yes, and then the fish going to the bathroom provides what the plants need. Exactly. Yeah.
Sure, you can do that. You can do the setup. I'm not setting up a knife.
No, that's a whole different project. Anyway,
it's really interesting. So that movie, he would not have grown potatoes. Was my whole point. Like, if you're going to use human leavings as a fertilizer, it would take months and months and months to break down, and you need soil to do it. You need bacteria, naturally occurring bacteria, to break it down. I mean, I like science fiction because I'm a nerd, but then there's things in science fiction that destroy it for me. I'm like, this movie's completely, no.
I was hoping when we were trying to think back that he had with him some, like, samples of the organisms that he could add, but I don't think he did.
It wouldn't work. But sorry to ruin that movie for everybody.
It was interesting.
It's like when I saw The Matrix. I was such a miserable person. I'm like the first time I saw it, I was like,
man, I'm glad I didn't watch that with you.
Why are they using human beings as a form of energy?
Yeah.
This makes no sense. You gotta feed them, house them, make sure they get fluid, they have waste.
Warm.
Like, this doesn't make any sense. They could come like your supercomputer. This is the best you can come up with.
Anyway,
part of being a nerd. Anyway, yeah, guys, I hope this was interesting and useful information. I hope it was brain retained. I try to present this stuff so it seems like logical, but also like contextual. You can relate it to something. And that it makes sense. But it's amazing, man. It's really cool. Like, you have this animal doing all this stuff to build chicken. Chicken has DNA that's telling it build chicken. And DNA says we need the ingredients to build chicken. So we bring the ingredients in, protein. Chicken uses it, breaks it down into these, well now we got trash, chicken says. And chicken's liver says, don't worry about it, bruh. I'm going to turn it into something so we can get rid of it. We'll turn it from ammonia into uric acid so you don't croak and get rid of it. And then chicken says, but I'm still hungry. I need more feed. Well, you know what? We're going to take your crap and throw it in a big pile and let it happen all over again where the nitrogen's taken out, broken down, converted, and turned back into nitrate so the plants can eat it so we can feed it to you again. Ugh. But that's what's happening. Amazing. And if you think it's really weird, wait until you learn about the hydrological cycle, how water moves around the earth. When you take a breath, take a breath. You just breathed in some oxygen that was inside of anybody, really, from history. Because we're talking about the number of atoms and molecules in a drop. It's amazing. So everything's interconnected. Biology's cool. Science is neat. But keep your faith, people. All right, is that it? All right. This was fun. I'm glad I got to do this last week. It hooked up on me, and I couldn't do it last week, so we did it this week.
Yeah, thank you everybody for watching. And if you have any more comments or questions or thoughts, feel free to leave those, and we will get back to you and interact with you further.
Until next time, enjoy the sexy world of chicken poop.
If you're new to our channel, feel free to subscribe and share the video. And if you had any thoughts as far as things that you want to learn about, let us know. So
I have some stuff I'd like to learn about. Well, we'll talk about this stuff. All right, guys, I'm going to go. Katie, Drunken Chef, if you're still there. Kelly, if you're around. Anybody else, thank you very much. Share this out, or at least tell people, hey, I found a nerd group who does chickens. Because usually people just sit around and talk about, I got chickens, and so this is, like you can say, oh, these people have usable information. It's kind of lecture-y, but still, it's fun. It's interactive.
Yeah, but thank you everybody for stopping in, and I hope that you have a wonderful rest of your evening or day whenever you're watching this. So, bye everyone.